So I guess we'll get started. So my name is Adam Attenberger. Today I'll be presenting Windows Stylus handwriting and integrating the Windows API into Chromium. So what is Stylus handwriting? It's a mechanism to seamlessly input text into any editable text field in Windows. So that could be the shell UI. For example, on the left, you can see the start menu search, or it could be an app like Notepad, or in our case, it'll be the render, it'll be Chromium editable text fields. And it can also support gestures. So there's 4 gestures at the moment. You can insert a new line by drawing a backwards L, basically dragging the line of text to the one below. You can scribble over words to erase. You can draw a line through words to select, and then draw a vertical line to split or join words where needed. There's currently 9 supported languages, but more will be added in the future. So for the scope of this talk, it's going to be covering the Windows text or handwriting API that was added, and integrating that into the Chrome renderer process for web contents. Vue's implementation should be a bit easier because it doesn't need to make that extra hop across processes. And there's just a few key differences that we'll cover for why that's a little bit harder in the renderer. So to get started, there's a few key concepts before diving in, and that's eligibility. So what content will be able to have handwriting? Intent determination. So did the user interact with something that can be handwritten? Target determination, which is basically adjusting focus based on some heuristics. Gestures, performing complex actions through predefined stroke shape. Then there's proximate character bounds, which is something that we need for the renderer process due to some performance limitations that we'll discuss further later. Then there's text services framework, which is a collection of APIs that Windows exposes for rich text editing. And then shell handwriting API, which is a new API in that text services framework. So for eligibility, we're planning to reuse much of the work that was already done for Android stylus writing. So basically it needs to be an editable text field. It cannot be a password. And in the initial implementation, it needs to have the touch action or panning both horizontally and vertically. In the future, we're hoping to add a standardized mechanism for this. Currently, that's not documented. So we've explored a few options. In Edge, you can define an HTML handwriting attribute, but we're exploring extending the touch action by adding a new handwriting keyword. But there's other options that might be possible as well. So the general flow of handwriting will kind of be this direct line. There's intent determination, then target determination, then focus handling, and then you can begin committing edits. But this is mostly for the recording. A lot of this will be repeated in these next slides. So intent determination, this is going to leverage basically a lot of the work that Android already has. So I encourage to check out their design document for the Android Stylus handwriting for a bit more detail on this. The gist is the user taps near something that's eligible, touches down near something eligible, and then begins a scroll gesture. That will basically be the signal that we're going to begin a handwriting. And we can start target determination. So the handwriting API will request focus for an area of the screen that's based on the early motions of the stylus. So you can imagine a small stroke will have a small box, but a large stroke might have a much larger box. And then we'll forward this to the renderer to handle the actual hit testing and focus setting and caret position if that's needed. And at this point, it'll collect bounding boxes. And I'll get into that a bit more detail later. Success or not, and the bounding boxes will be forwarded over to the browser process, where it can then notify TSF whether focus has changed, and it can notify the handwriting API that it has a focus or not. If there is no focus, then handwriting ends, and if there is, then it can continue and begin committing edits. So the handwriting API will call to the text services framework APIs for inserting text or selecting text, and that's where this happens. So a bit further on target determination, you can kind of see in the example on the left, the user's missing the box that they're beginning to write in, but it can figure out based on this requested area what the user likely intends to be drawing into. Very naively, you can see that like it's taking the center point of that area and doing a hit test there. There's a bit more information available through the API, such as a tolerance value to basically allow you to hit things that are a little bit further away. Don't worry about that. But the reason for this is if you tap something, that may not be the element that you intend to be writing into. And you can kind of see that in the second example there where they've tapped outside, but we're writing in the box below it. To compare different implementations, you can see Windows on the left is based on that focus area. Android is based on the initial touchdown location. So even if the user scribbles far outside that initial tap, it'll always insert into the box that it was first touched. And then iOS is doing something kind of hybrid between the two. So the initial touchdown triggers a focus, but then as they drag over the next field, it moves focus into that field. And then for the proximate character bounds, this was kind of an optimization that was needed for the renderer process specifically. So based on that target location, we can derive a caret position, and then from there only query 100 characters forward and backwards from that position, and only report those bounds. That should be a good approximation for what's needed to be able to support gestures. And for browser and view content, that won't be a necessary step because all that information is readily available in the process. So we don't need to like marshal any data across process boundaries.
For gestures, you mean things like gesture to like move forward a word or back a word, basically things that involve the actual text?
Yeah. So like split join, it needs to know like what is near the characters so it can then determine like an offset, and then is there a space there or not, and then do the appropriate action, adding or removing a space. And as well as like selection, you need to know where the word boundaries are and so forth. So why is this really needed for Windows though? So in Android, when it's performing a gesture, the API forwards that information opaquely to the app. So the app is aware that Handwriting is attempting to do a split join or a select, and that information can be forwarded to the renderer process to be handled. It can then send that back and say whether or not that was successful or not. If it fails, then it can do text insertion. But Windows does this opaquely. So it will handle all the gestures in the background. Like the app won't be aware of why the edits are coming through. It just knows that the edits are coming through and it needs to make them. And it'll start with that pivot position, expand outward until there's a failure in both directions, and then use that as the context for determining what gesture, if any, was likely performed in that area. So the Handwriting API will call the existing TSF, the Text Services Framework APIs for get ACP from point. This will inform it of what character offset is basically the starting point, and then get text.txt, which is collecting the individual bounding boxes based on the offset. And again, for views, it doesn't need to do this. It can just query that data directly, and we can synchronously provide that. So to share some metrics, for future usage, there's about 13 to 19% of devices that in Edge that used Stylus input for a given day that were handwriting capable and used handwriting at least once. So it's kind of a very big metric, but that should translate over to Chromium in general. Of those, about a little bit over half of them were intent taps. So it was, sorry, not taps. They were basically initiating a handwriting session. Then of those, only 6% of the target determinations had resulted in a miss hit. But 82% of them resulted in no focus change because they continued writing in the same field, or the field was already focused before they began writing. But 12% of those resulted in some focus change. Either there was no focus before, or they needed to focus an adjacent text field. And to kind of illustrate why the proximate bounds cache was needed, in the general case, in the median case, the performance isn't too bad. It's about 0.5 to 1 millisecond and like time to collect it and then have it ready. But in the worst case, it's a little bit over a frame, between 10 to 22 milliseconds to do that. And then for some of the issues that we're kind of working through, so large text area editors like Microsoft Word or Google Doc, where the entire screen is an editor, we'd like to kind of improve this for kind of usability. Like you may want to scroll in those scenarios, and that's kind of where the HTML handwriting attribute or the touch action kind of comes into play. Like being able to control when you want to handwrite is going to be important, as well as the sheer amount of content. Like it would be ideal if we didn't need to do the proximate bounds cache, but in reality, that seems to be necessary based on some of the metrics we're seeing. For dev tools, we're not really sure if it makes sense to expose anything to dev tools as far as handwriting, or like what might be useful information to provide. beyond like timing metrics. The views content, we'd like to unify kind of how the render and views and all that are hooked up with handwriting. And one of the kind of tricky issues is around focus. There's some scenarios where you could begin writing in a field and the focus could move underneath while you're still handwriting, and it could insert into the wrong field. So that's one of the trickier problems we're trying to work through right now. And of course, we'd like to expand the cache or make it not necessary so that we can have all of the bounding boxes we need to support gestures. So kind of back to like whether or not an element should allow handwriting. The current implementation is based on having both pan X and pan Y. One of the difficulties with that is it's not possible to separate handwriting from scrolling because the combination is what allows handwriting currently. So you can turn off one direction of scrolling to turn off handwriting. But if you wanted to have both, that's currently not a possibility and by using touch action in its current state. But we're talking to the CSS pointer events group to add a new keyword potentially, and maybe some other changes if we need a little bit more granularity for that. So there should be a PR in that area soon. And then for references, there's a few links to like the different design docs and the CR bugs that are tracking all of this work, as well as the work that was done previously for the Android implementation. And I'd like to give a special thanks to everyone who was involved in enabling this behavior in Edge and soon to be Chromium. So Ben Mathwig, Claire Chambers, Jenny Ma, Olga Cherchikov, Rahul Akari, Sahir Vilani, Yaroslav Shelvisky, they all helped with integrating a lot of the API or organizing things. And then on the Windows side, there's Jess Hallett-Hook, Pankaj Tanwar, Parth Saharthi, Sanjana and Yifan Wu, all who helped on the Windows side to enable this on the OS layer and with Sex Services framework. And with that, I guess can open questions.
On the very first slide for the workflow, you talked about like capturing the scroll event in order to sort of detect when like on pen down that the user started writing. I want to understand like how that, I'm assuming that that's a heuristic essentially, that like the some part of the system, I don't know if it's Chrome or Windows, can tell the difference between the user taking their pen and being like, okay, I want to scroll up, and them taking their pen and starting to write. Is that a heuristic that's going to be built into Chromium, or is that something that the handwriting framework sort of provides a signal that like this pen movement looks like handwriting, or no, ignore this pen movement, it's scrolling?
Currently, it's not necessarily a heuristic. It's treating handwriting as panning, as scrolling. So it takes precedence over scrolling if there's a editable field.
I see. Okay. Okay.
Yeah.
So it's sort of similar to, I'm not sure what it's similar to, but it's basically like if I, if I like put my pen over here where there's no like content, then it would
Mhm.
scroll. But if I put my pen over here, because it's text box,
Yeah.
it's gonna not scroll.
Yeah, exactly. So yeah, that's kind of where um, the touch action attribute comes in. We'd like currently that's how you can say, even if this is edible, even if it would be eligible, we don't want it to be eligible.
Okay.
Um,
That's why the pan XY stuff is there, because when it's the
Yeah.
thing that says I clearly want to be panned, then you don't want to activate writing mode. Okay.
Yep.
That all makes sense.
Yep. And we'd like to add an attribute to differentiate between panning and handwriting, but allow the user agent to still take the preference of handwriting if it wants to, but give developers a little bit more control over the experience in their particular app.
Are there any questions from remote participants?
I'm not sure how to see that in here.
I was asking.
Oh, okay.
What's the current shipping state again? Is it in Chrome or just Edge or both?
Currently, it's shipped in Edge. The implementation is quite a bit different, but we're in the process of moving a lot of the code that we can upstream with the same architecture that was used for the Android stylus writing. We're trying as much as possible to leverage what was already there, make it a lot easier to make modifications that can be shared between the two implementations. But there will be just a couple of differences just because of the API layer. We're still pretty early in the migration, though. We have a prototype branch that is functional. It's definitely not in the final state, but it is there. We're kind of taking pieces of it and then moving it over to make it a little bit easier for review.
Does this work both for views and renderer edit controls, like both leverage bar and renderer edit controls?
Currently, the prototype is just in the renderer process, like getting that plumbing in, and because that's going to be the bit trickier pieces to get in.
Which entity is responsible for doing the stroke overlay?
The operating system is. The ink is overlaid through the tech services framework, and that's part of the operating system layer. Right. It's also, I guess, it's also worth noting that once handwriting is confirmed, so we've confirmed focus, the tech services framework will also consume inputs for the stylus, and then relinquish once it's completed. But yeah. There we go. So I guess, are there any other questions?
Where would most of the changes to make this happen in Chromium be? In the renderer, browser? Where would you be changing?
What's that?
Where would you be changing code to add support for the in Chromium? What components of Chromium would you be touching?
The components we'll be touching are mostly Blink for obviously for the round trip to get focus and character bounds and things like that. And then the content layer, there will be an object that interfaces with the handwriting API. And basically that one object will handle all the outbound and inbound communication for the API.
And that happens in the browser process?
Yeah, it's all in the browser process. It's next to the TSF bridge because it's kind of coupled to that.
Basically at time, anyway. Thank you.
Oh, yeah, yes we are.